So which is related to the logistic regression and as well as decision tree modeling. So in the earlier sessions, like we have seen some of the classification examples. Compared with those classification examples, these two are a bit distinct. So reason is very simple. These two aspects are having a separate, I can say, a separate some kind of the special characteristics in case of the functionality and as well as in case of the accuracy also. So that and especially the decision tree model, which is quite interesting, whereas I can say this particular decision tree model basically helps us, okay, so as to focus on some kind of decision modeling and as well as to solve some kind of the complex problems. All these aspects can be observed as a part of this particular decision tree model. Now, so let us give a brief introduction of these logistic regression and as well as the decision tree models, and then we can discuss the examples. So can someone help me, friends, what we have seen in the earlier sessions of the logistic regression, and thereafter we have seen some kind of the sigmoid function. This is one thing, and if I am referencing the usage of logistic, though it is the term regression, the logistic regression belongs to the category of the classification. Okay, so now as usual, friends, if I am referencing the sigmoid kind of the function, one simple notation here. Okay, so just if I am working with the simple or multiple linear regression, whatever the values I am taking, maybe experience and as well as the salary value if I am taking, so just there is a kind of the relation, maybe like this, and I am performing some kind of the line. Okay, so this particular line shows that maybe to the given experience, what is the salary value correspondingly. So it is showing some kind of the relationship between experience and as well as the salary. Okay, both in case of I can say in case of simple linear regression and as well as the multiple linear regression, we are having the same convention. Okay, now one more important thing is do really we will get this kind of the straight line, friends, in the reality?
No.
Really, because according to experience, suppose if you are saying like this, so maybe some data if I'm considering, and we'll take the current example, what we are going to work out. I'm having some kind of the age and salary of the corresponding person, and whether that guy has purchased the product or not. Okay, so maybe some kind of the age wise, if I'm taking only one particular thing, age or salary kind of aspects, maybe I can see some different aspects. Maybe I can say this particular curve as some kind of the S-shaped curve. Okay, this is S-shaped curve. Is a curvic nature, friends. Now tell me one thing, whether establishing a straight line gives the proper relation, or this kind of the curve will give the proper understanding, or proper understanding in the sense results wise I am talking, maybe accuracy or prediction, because however we are talking about the classification techniques, so definitely there should be some kind of the aspects where you can reference these kind of the points. Now what is the benefit? Okay, what is the use of this particular logistic orientation? So that one we have to identify. Let me give you the equation what exactly we are looking for. Let me pull that. So the logistic regression, so basically is a technique which is borrowed by machine learning from the field of the statistics. Okay, and is a binary classification technique, friends. What do you mean by binary and multi? The most standard question in the interviews also. How can you refer the multi or binary classification? Friends, are you there?
Sorry, can you?
No problem. Yeah. What is the difference between binary and multi classification?
Binary is like just two S and no kind of thing.
Yes or no kind of thing, or true or false. Multi classification, friends, maybe yes or no, maybe, or else sometimes, there are certain aspects. Maybe the people belongs to the degree in computer science, or
Like we have this, the sizes, t-shirt sizes, small,
t-shirt
big, large.
sizes.
So
Yeah,
can
right.
be
Exactly.
all have equal importance.
All are equivalent. And multi classification, maybe more than two, like three outcomes or four outcomes. Usually we won't get those kind of thing. But however, if you are talking about the binary classification, majority of the times in classification we are expecting yes or no kind of the aspects. And one more important thing that time we have seen, what it does, friends, in the logistic regression. What is the main thing we have observed there?
Logistic regression, it still um,
Let me, yeah, okay. I have picked up some of the points which you can see in your earlier we have seen the same. Again, to set the context, just I can refer the same points for you. So if you are focusing on getting the logistic regression kind of things, friends, basically is a technique borrowed by the machine learning from the field of statistics that we pretty know. And another important thing is just if I am making use of 1 minute, guys, this thing, yeah, is the go-to method for binary classification, because as this regression is belongs to the category of the logistic regression is belongs to the category of the classification, yes or no, true or false kind of thing. What do you mean by logit model, friends? Is a regression model where dependent variable is categorical. Now again, independent variable. Dependent variable means y. Your independent variables are x1, x2, x3, and so on, xn. Now what we are doing is just we are making use of a regression model where the dependent variable is categorical. What do you mean by categorical, friends? Because data might be in categorical data, or sometimes it is because many at times, understanding of various data items is also important. Okay, so basically this particular category. Okay, so where if I am getting my dependent variable y value as a categorical kind of the aspects, okay, so that I can say this kind of regression is very much suitable. And logistic regression measures, this is pretty known. So categorical dependent variable and one or more independent variables. One of the important point, friends, here, probabilities. Okay, I can observe the understanding of the logistic regression is with the help of the probabilities. That means it is naturally expecting the predicted, okay, whatever the independent variables and all. Now, suppose I'm having some values, I need to convert these particular values into the probabilistic values, because this logistic regression, while talking, this particular regression is observing the things, input values in the normal things, and it is going to convert those values into the probabilistic values. Now, in case of the regression, what is the formula, friends? What is the formula we have used?
Beta,
That one, beta naught plus beta 1 x1 plus beta 2 x2 plus so on, beta and xn, and there we have seen some coefficient and as well as the intercept value. Those things we have seen. That is a straightforward thing. But whereas at the moment I am talking about the functionality of, okay, regression, especially the logistic regression, there is certain kind of the equation. So where you can observe the functionality of the logit function. So it is a probability between happening and not happening kind of thing. Okay, so there we have said that thing as a logit function, if you remember, friends. Okay, so just let me pull that particular thing also, because this particular logit function, interview wise they ask about how this particular logistic function is distinct with the normal regression or multiple regression, because both the things are comes under the category of the regression only. But simple linear regression, multiple regression, polynomial regression belongs to the category of the regression. But whereas the logistic regression is belongs to the category of the classification. Though we are talking about the regression name, but still it is having the usage of the classification. There in the stats background of logistic regression in our discussion, just we have seen some kind of log sorts ratio, this one. That means probability of an event occurrence and probability of non-event occurrence. This is also known as probability of happening, friends. Actually, this is p value. Of course, I can say p by q or else p by 1 minus p, because in a typical probability understanding, your p is true and 1 minus p is false, friends. Actually, okay, because in probability we say happening as 1 and not happening as 0. That means 1 minus 1 as 0. Either you can refer p by 1 minus p or p by q. It all depends on the kind of the understanding. So just you can apply the logit function, where this particular logit function is taking care about understanding of the probabilities. So p however is the happening, and 1 minus p is nothing but the not happening of that particular event. Now, if you are referencing the sigmoid function, okay, how to refer that particular sigmoid function, friends? There is one simple equation we have seen that time with the example also. So now let me pull that particular thing also. Okay, these things are not required for the implementation. To be frank, only just we are making use of the logistic regression. But nowadays, friends, a simple statistics also they are asking in the panel. Okay, in fact, we are also just if a person is knowing about the logistic regression, he should able to know about what exactly the stats behind that, at least in a minimal way. Okay, so for that particular purpose, again I am iterating so how we are using the functionality of this particular logit function. So as mentioned earlier, just you know the difference between the normal regression and as well as the logit is, in case of the normal regression we always prefer the line, though it is not practical. So just we try to expect the appropriate relationships in the format of the line notation. Whereas if I'm talking about the sigmoid, okay, this is S-shaped. That's what we are saying, that as a sigmoid kind of thing. So this particular sigmoid is a kind of the logit function, and this particular logit functionality as a logarithm is entering, and we are having the exponentation also. Okay, just to remember, with the in terms of p by 1 minus p, you can apply the log functionality, or else logit function, or else exponentation of. Okay, this kind of functionality you can observe while establishing the sigmoid function. Now, one more important thing, friends, here, uh, which are all the assumptions, friends, in case of the logistic regression? Assumptions
Uh,
are there now. Some of the assumptions we have seen.
Additive rule, is it the same that applies for the other
Same,
regression?
yeah, all because these regressions are follow the same convention.
Heteroscalicity,
Ah,
homoscalicity, additive. We talked about additive.
yeah, additive property,
The
auto
thing,
correlation,
autocorrelation.
all these things, you know, nowadays in all these logistic, if you are putting logistic regression experience in your resume, definitely they will ask about what exactly logit function, what is the difference between linear and logistic regression, why logistic regression is belongs to the category of the classification. Okay, which are all the metrics, because you know generally people think that these measures or metrics of the regression are similar with logistic also. Because you know regression metrics we pretty know, which are RMSE, RAE, and R2 score. All these are the things which are related to your regression. But whereas logistic regression, what is which are all the metrics, friends?
Confusion matrix.
Same confusion matrix, because this is a classification model.
CROC, yeah.
Classification model. This particular classification model helps us to observe, so just it is providing us the classification report, and then confusion matrix.
AUCROC also, yeah.
The UCROC is also there, but nowadays we are not using,
Okay.
because this classification report and confusion matrix are most commonly used things. Apart from that, we have used nowadays accuracy score also we are using, friends.
Yeah.
Okay, this particular accuracy score, because it is directly giving the accuracy of the algorithm. Okay, now can someone help me, which are all the application areas of logistic regression? Application areas of logistic regression. You can see the whatever the things I have shared earlier, because this thing also they are pretty clear. Email spam or ham, because rather than giving the values, if I'm giving the probabilities, just observe, friends, probability based. Okay, if I'm saying probability based algorithms, can someone refer that, friends? Probability based algorithms.
We have naive bias.
Okay, naive bias is one of the algorithm where, but which kind of the probability it is using? Conditional probability, na? Conditional probability, and it is making use of some kind of the Bayes theorem, actually. Okay, Bayes theorem. And coming to the logistic regression, friends, what it does is whatever the values I'm having, these values are converted into the probabilities, and the kind of the probabilities whatever we are using, so just the value should be converted to the probabilities with the help of the sigmoid. They may ask you what is the difference between sigmoid and as well as the normal regression equation. Sigmoid, which is a shaped curve where you can refer the kind of the points. Generally, in case of normal regression, we are always talking about this particular line, straight line. Practically, it is not possible, but that's how we habituated to use the linear or multiple regression. But whereas in case of the sigmoid, this is curvature, actually. Some kind of the curve which is really giving the benefit of understanding the exact relationship between the variables. And moreover, friends, just to observe, always it is good to say the probability value, probability rather than the value. What is the reason behind that? Always we are
no, that is the chance of occurring. The
chance of occurring, actually. We need not worry about the appearance, or because only the thing is we're guessing.
Yeah, it's a classification. Anyhow, we are not dealing with the values, so we always see whether there are only two possibilities. One is yes or no. So
yeah,
always
that's it. That is one of the important aspect. Now, if someone asks you the applications, already we have seen email spam or ham, or else some kind of a transaction, whether the transaction is um, erroneous transaction or some kind of the fraudulent kind of the transaction. And moreover, friends, HR status, whether this guy is join or not join, based on the way he responds, and after taking the offer, maybe he is not joining. Maybe he's taking offer for the sake of demanding the current company. All these things would be there, no? So like credit scoring, whether that credit score is good or bad. Okay, so all these kind of the things you can observe. Okay, now, what is the benefit, friends? What is the advantage of this logistic regression, by the way? The results are interpretable. So because once you take the chance of this logistic regression, you can highly interpret the results. And moreover, friends, model training and predictions are very fast, because internally, if I am electing that logistic regression, it is following the logic functionalities or sigmoid kind of thing. Though you are not explicitly mentioning those points, but still it is enjoying the benefits of those particular stats behind the scenes. And one of the important point, friends, here, suppose if more number of the features are there, which you can be which you can say as a best algorithm, friends, if more features are there. So far we have taken some of the algorithms, like we started with which algorithm, friends? We have started with
linear.
Okay, which we have started with some of the algorithms. Let me write down so that we can have a quick recap. The very first one is, friends,
Linear
regression. Yes.
multilinear.
Multiple linear regression.
Multiple KNN.
And thereafter, the third one is the KNN. Fourth one, what we have seen?
SVM. See, SVM, naive Bayes and SVM. SVM works. We have a lot of parameters.
SVM works with a lot of parameters, and naive Bayes also. Now the sixth one we are talking now, logistic regression. Now, friends, here sometimes this naive Bayes and as well as the SVM, these are good for more features. In the opposite direction, works good for small number of features also. See, friends, which is maybe we are not consider this point as high kind of importance. The point here is very simple. Generally, in case of the data science space, we're having some features, and you can go ahead with the SVM or naive Bayes. What is the specialty of the SVM again? Out of these particular algorithms, it is having some specialty, na?
It works for both linear and non-linear.
Non-linear, and that we are having the kernel trick, na? Actually, how many kernel trick functionalities we are having? Most frequently asked question, friends. Repeatedly nowadays they are asking radial basis function, sigmoid function, polynomial, and linear. Okay, like that we're having different kernels. Now, can you say uses of this particular radial basis give the high accuracy or prediction? Can I?
No, we cannot say by that.
We cannot say that, okay, because maybe sometimes the data internally may contain the linear relationship. If any demand is there for applicability of the non-linearity, then only you can go with the RBF or those kind of the functionality. Otherwise, it is absolutely right to go with the linear model. Okay, so that you can. And one more point we have explored, friends, in the SVM discussion. Can you bring that point here? Along with all these kernel.
Grid search CV.
Very good, very good. Okay, what is the benefit of that?
See, it only gives a best result out of if there are a lot of features. It optimizes the best among them, and it gives the solution.
Yeah, actually the parameters would be different, huh? Maybe penalization parameter, and we are having some kind of the kernels, but we are not sure. We are not sure whether, of course, we can go by this brute force applicability, but it is not always good now, because however we are having the grid set CV kind of thing, where I can supply all my parameters, and that grid set CV itself suppose supports us to give the observation of, okay, what is the best parameter to use so as to get the corresponding outcome in a better way for the identified data set. So that is what you can refer the notion of this SVM. And coming to the other point, the logistic regression in other way around, it is works good for a small number of the features. Okay, that means suppose what I'm doing here is starting from the naive bias support vector machine. Now we are dealing with the logistic friends. What I'm doing here is the same data set. The customer data is there now, where we are having that age, and thereafter what is the other feature? Salary, whether he has purchased the appropriate car or not. Okay, maybe the SUV company is having some kind of the data. That manager thought of building a model with the available data science team, and has given that particular data set to us. And so far we have seen some kind of the accuracy scores with naive Bayes, SVM kind of thing. Now what we are doing is we are going to apply with logistic regression, and let us see, because now a simple point here is however features are very less, only 2 features we are having. Okay, I can make use of the logistic regression. And one more important thing is the values can be observed as a probabilistic values. So this is one of the important point we have to observe. And any other things we need to observe, friends, in the logistic regression? Do we? Any specific kind of the thing not required now? Because that particular logistic regression, however, is providing the way of observing the things. Okay, so that we can straight away make use of the things. Okay, now many a times, you know, again we are going to talk the same kind of the template. So because why I'm showing these things without giving to you is you should habituate, friends, because however first is the importing of the libraries, and thereafter handling of this particular data set. Okay, so and once that particular thing is over, the next important aspect is I should refer. Okay, so once the data is available, so we have to train test split. This is also normal. We'll come back to that point, friends. Again, I will explain. And thereafter feature scaling. Okay, why we need to scale, friends, here? Because in logistic regression, one advantage is there. Without scaling also, you can think through. But the problem here is we are having age and salary. We are having age and salary, which is causing some kind of the effect on the algorithm. So algorithm may feels that this particular salary is having high impact and all, but we are considering age also. No, that's what we are doing the feature scaling. And then what we have done is just to observe here, friends, one simple equation from scalar dot linear model. Somewhere we have seen the linear model where we have seen, friends, because this is
SLR and
yeah, linear and multiple. That is what, friends. Venkat, you asked one question. Do we need to follow the same kind of assumptions in the regression, logistic regression also?
Yeah, correct.
Okay, na?
Same. Doing this.
Same. Because, you know, the family of this linear model is grouping the linear and as well as the, multiple linear regression. Whereas we are having the non-linear models also, friends. Recently, one of the interviewer asked in my panel, what is the difference between linear and as well as the non-linear model? Linear in the sense where we're having all the equations in without any squares, cubes, or something like that. Only we are establishing a relationship between x and y or x1, x2, those kind of the things. Non-linear thing, non-linear means x square, x cube, some kind of the additional values. Okay, if you are if I'm making use of those kind of x square or x cube kind of the things, then you can go with the non-linear. We'll see the poly, though it is not in the curriculum. I'll bring some of the case studies related to the polynomial regression, friends. Okay, so because that particular polynomial regression is not distinct with the linear models, but at least one non-linear model in the regression will try. Okay, no problem. So just as usual, just we are putting this logistic regression. What do you mean by random state actually?
If random state is one, it can be applicable to
all kind of the algorithms. Okay, what it is doing, logistic regression, or it is also known as logit or maximum entry classifier. Okay, and in the multi-class case, this is one of the important thing, friends. I don't know, though we are not using, but I'll try this particular discussion also, because sometimes you may get the senior members who are having this kind of issues in case of the multi-class case. It is using some other way, friends, actually, though the same kind of the logic we are using, just it is making use of these advanced things like entropy and all. Entropy I will discuss in the today's session only, with a nice decision tree example. So however, we are having the logistic representation. So this particular regression helps us to identify, somewhere I found this particular random state. So random state instance used to shuffle the data. Okay, because in the earlier examples, the same kind of the thing, suppose if I'm applying my SVM, naive Bayes, and as well as the logistic regression on top of this particular sales data, I should keep this particular random state as simple, because it has to see the same shuffle, same shuffle it has to observe. So what we are doing is only we are making use of the same kind of the shuffles. And moreover, as usual, just if you observe the fitting of the model, the parameters as X train and as well as the Y train. And then this we have seen from the naive Bayes and as well as the SVM model. So what we are doing is just we are giving one age and as well as the salary, and we are trying to get whether it is giving exact result as that of the original data or not. And we have succeeded the same kind of the result. Now, why we are publishing this particular test results is somewhere if any mismatch is there, suppose it is a mismatch actually. Okay, so because our prediction has given 1, but actual data is 0. And similarly somewhere, okay, our prediction has given 0, but he has purchased the SUV, like some rare. Okay, so not exactly all the things, but somewhere in a scatter way. Yeah, here also some kind of mismatch is there. One or two would be there, na? And that too, in case of the classification, we are having this our model as a confusion matrix and as well as the accuracy score. So if you observe, friends, what is the accuracy score in naive Bayes and SVM? Can someone quickly give the answer?
91, like that, 91.
One is 91 we got, and in naive Bayes, if I'm not wrong, we got some 90%. That means the logistic is not doing well on the data set, friends, actually. Okay, this particular data set, naive Bayes and SVM are better. Okay, now let us explore. So however, we are having NumPy, Matplotlib, and as well as the pandas. What is the use of NumPy, friends? Some kind of the statistical functionalities and numerical kind of the things. Matplotlib, though we are not using the visualization, sometimes there is a possibility of understanding the things. That again, I will give you that, friends. Okay, Matplotlib, and once again we'll see Seaborn. Okay, all these things I'll give you some kind of notation. And pandas is most commonly used library, friends. After the sklearn, the most commonly used library is pandas. In fact, while reading the data and while working with the data frame kind of the aspects, we have to perform all these things in the with the help of the pandas only. Okay, now this is a data frame kind of thing where our customer purchases data is available. What is this ILOC and LOC? ILOC.
Internal thing, which is
internal thing, which is by default. That means just what we are doing, except the last entry, we want to pick up all the features into the X value. And the second one is dataset.ILOC, last entry. So just we are not using any colon kind of the aspects. Now splitting the train and test data. If I am making use of the model selection, earlier we used to have that k-fold cross validation or cross validation kind of thing. Nowadays, friends, we are not requiring those kind of the thing. Directly our model selection itself is doing a proper train test split. Maybe after 5 or 6 months in our company, you may use some other method. Okay, and this is as usual from starting from our training test set observation. Okay, just this particular function, this method is returning four parameters, four outcomes actually, x train and as well as the x test, y train and as well as the y test. This particular x train, y train we are using for the fitting of the model. Our x test is used to generate the predictions, and after generation of the predictions from the x test, we are going to compare y test and as well as the y pred, so that we can make use of the convention related to whether we are doing in a proper way, our model is doing better or not. Now at the moment you observe here friends, in train test split the random state is different. Okay, if you observe the random state here, maybe earlier if I'm asking, I asked you to observe the random state. This random state is related to the kind of different algorithms. Okay, so this is however features, y is nothing but the label. Test size here 0.25 I have used, so that obviously your training size would be 75%. Random state I am using 0. Maybe if I am asking you guys, so you can pull all the usage of that SVM and naive bias in the same notebook, Jupyter notebook, and you can compare the appropriate predictions and as well as the confusion matrix. Okay, so that just you can apply on the same data set. On the same data set you can apply, and of course, though logistic regression is not doing well in this particular example, we cannot say logistic regression is behind the naive Bayes or support vector machine. Why, friends? What is the reason behind that? Because this is also one of the important aspect we have to observe. Though for a particular in a particular case, our logistic regression is giving some kind of the less predictions when compared with support vector machine and as well as you know that naive Bayes, but logistic really doing well compared with others, because it is a shaped kind of thing. It is making use of the probabilities. For the lesser number of features also we can make use of the logistic regression. All these points are there. Now still getting off less accuracy or less score doesn't mean that we should go with some other aspects. We should not do that, friends. Okay, because it all depends on the particular case of the data set. Maybe you can fine tune, or you can use some kind of the hyperparameter tuning techniques. Sometimes we can get the improvement also. Okay, once these examples are over, once these algorithms are over, probably in the next or day after session, we'll come to this gradient boosting, vanishing gradient, because those are also very important aspects in the landscape of our machine learning and deep learning, friends. Okay, so and thereafter we'll see the convolutional neural networks and recurrent neural networks, some aspects. Okay, they may not touch base on those kind of things, but at least if you are knowing, means you will be getting one more plus with the usage of that CNN and RNN kind of thing. Okay, and NLP, however, we have seen some kind of the artificial neural networks, NLP kind of the aspects, all those things. Okay, just to be ready with all those kind of the things, friends. Okay, now what we are doing is just we are printing all those four parameters which we have generated from the train test splits, nothing else. And thereafter the thing here is why we are scaling here is one simple point, because if I'm having age and as well as the experience, I need not scale anything. But if you are having experience and as well as the salary, or age and as well as the salary, there is a lot of gap is there between age and sale component in terms of values. So in that particular case, friends, definitely we have to maintain a common scaling. This is obviously we have seen whether I need to apply the scaling before the split or after the split. Long back we have seen in the first algorithm itself. Features before or after. Now what we have done actually, after splitting the data, we have done feature scaling. Okay, that means maybe this is a model selection and this is a pre-processing kind of thing. Yeah. This is definitely a pre-processing. This is a definitely pre-processing. So though we are after this particular thing, and to be frank, friends, but not much differentiation. But you can do one thing. before train test split, just you can apply this particular feature scaling, and you can record your observations. Okay, because earlier I have given some task to you. Just you can go back and verify that one note, and you can collectively set all those kind of the tasks. And in this weekend, what I will do is just I will share some kind of the tasks to you, like 4 or 5, just maybe explanation or some kind of commonly asked questions, and there we can discuss. I'll give a chance to some of the members so that we can have a discussion, and parallelly we can derive what exactly the current trend and all. Now, one more thing, friends, here, while talking about the software engineering flow, and as well as this Java and Python, that full stack development is completely different. They gather the requirements, and then they start the design phase, and thereafter they can establish some kind of the coding and testing. It goes like that. But our data science a team of intellectuals, no, like subject matter expert would be there, and thereafter some of the developers maybe from Python or Scala would be there. And if you are in the team of data engineering, though you are not having big data kind of the background, but some of the people would be there to help you to load the data and to give the data in the CSV. Like that, you can perform these kind of the aspects. Now, if I am asking you, what is the life cycle of data science project? We have seen many at times. Can someone quickly refer, friends?
The life cycle?
Life cycle of the data science project.
We start with the problems statement, then we like gather the data.
Okay.
We do the pre-processing.
Very good. Pre-processing. Pre-processing means again question may comes.
all this like from
missing value imputation, encoding
value,
techniques,
and then test train split standardization.
That's it.
And we select the
algorithm.
appropriate
Algorithm. Maybe that is a, if you are classification, then you can choose a KNN, naive Bayes, SVM kind of thing, or decision tree. Whereas if your model demands the numbers like linear or multiple, accordingly you can select the option. Once that is over, then
this one, the measures.
Model evaluation, metrics or model evaluation. So that means, friends, here the in every case study we are really doing some kind of the process. Actually, if you observe, starting from the import of the libraries and loading the data and performing some kind of the missing or encoding kind of the techniques or feature scaling, train test split, and then just within this common method is a standard scaler. For that, just we are making use of this fit and transform for the extrains, because all these extrain is containing age and as well as salary, whereas this particular X test is only containing outcomes. So no need to fit. These things are not participating in the model building, so that we are not fitting anything. Fit is coming into the picture whenever you are building the model, friends, not in the testing. Okay, and once this particular train test has been converted into the kind of scaling, just what we are going to do, friend, we're now on top of those kind of things, we are going to apply the logistic regression. So what is the difference between earlier classification techniques and this one, friends? In the earlier classification, we are having some neighbors, n neighbors, and there we are having the k nearest neighborhood. Like in case of the classifiers, we are having the SVM and as well as the naive Bayes. But linear model generally refers to the linear and as well as the multiple regression. The same linear model is also having the accommodation with the logistic regression. Let me give you this thing. 1 minute, friends. Okay, 1 minute. Just I want to share some kind of the scikit-learn. Just to observe here. Yes. See, just if possible, friend, just you can explore this kind of thing, which is a standard documentation. You can as it easily use these things actually. Okay, like if I'm saying the scikit-learn kind of thing, we're having the classification, which is SVM, k nearest neighborhood, random forest. Okay, all these things. Regression, support vector regression, but don't go beyond this thing. Regression, you remember that like linear, multiple regression, all these things only. Okay, because one convention here is, friends, though decision trees, random forest, and support vector machines are used for they can also use for regression, but that's not a regular practice. Maybe at times, if you want to perform some kind of the heterogeneous kind of testing, maybe my classification algorithm, I can make use for the regression as a kind of experiment. You can go, friends, but in a typical environment, we don't do that, to be frank. And what do you mean by clustering actually? Clustering, have you seen?
Non-supervised.
It's not the supervised kind of thing, unsupervised learning.
Pattern, it gives the pattern.
It is very simple, friend. Suppose if I'm giving some kind of the dimensions, longitude or latitude kind of thing, I should cluster based on those measures. I should cluster the countries. Okay, so just you see here, just it is saying. And one more the example we have seen. Suppose the people who are having the higher salary but they are not spending more, the people who are having higher salary and spending more, lower salary more spend, lower salary low spend. So these kind of the groups would be there. So if I want to maintain a kind of the convention, I can go ahead and maintain the convention of the clustering. Most importantly, friends, this dimensional reduction. Somewhere we have seen this one, where we have seen this dimensional reduction.
In
common question, friends. This is also
in the measures we have seen where we reduce the number of
features. And one more thing, low value filter, high correlation filter, something is coming into your mind, missing value filter. Friends, believe me, very important. That is very important. Okay, because every
regression when we calculate the regression coefficient,
there also we have used. Okay, and one more thing you observe, and now I'm going to introduce the decision tree also in the session. One more important point, friends, here, if you remember, decision tree and random forest can be used for the feature value selection. Which are all the features and which feature is really helping or really contributing to us, and which feature is less contributing. Okay, that means it is giving a kind of the graph or kind of the values where you can perform some kind of the aspects, like with the help as a byproduct, friends. Actually, yeah, I'll give that particular example also once we'll complete these kind of the algorithmic notation, because our focus is on the algorithms, and later I will give above and beyond the things. Okay, and one more important thing is this model selection. Out of the available models, which one is good? For that, we are having these things now, maybe metrics like cross validation, metrics, all these things, and grid set CV. Already we have seen. Suppose I am having various parameters and I want to perform some kind of the activities, okay, on those kind of the parameters. So to come up with the best one, I can make use of this model selection. Pre-processing, a lot more are there. If you are selecting this particular pre-processing, just it is standardization we have seen, mean removal or variance scaling, okay, low value filter and high variance filter. Okay, some examples also they will give, friends, actually. So because out of these things we are using strictly, we are following some kind of the data science scenarios, so that we are making use of the convention. Okay, right, based on the examples we are dealing with, guys. Okay, and some outliers also we have discussed it. Can someone give some example where we have used that outlier detection? We're having some kind of examples now. In case of stat model statistics, friends, you have to revise. Okay, mean, median, and percentile. Out of these, which is the best method to get the outliers?
Median, we can do from median.
It is not influenced by the outliers, but percentile is the good calculation, na? So that interquartile range is there, the 25 percentile, 75 percentile. So whether our data is properly moving ahead, all these conventions you can easily specify. Friend, don't feel that data science or these things are something not relevant to us. By this time you would have realized only the thing is your hard work. And one more important thing is keep on preparing, friends. Okay, nothing is beating the hard work and all. Okay, that is one of the important thing. And one more thing is logically you need to connect the dots, because more or less in the seventh algorithm, sixth algorithm, we are seeing the same kind of the convention. Okay, by this time, you know, just you can follow up all the importing and the loading of the data, missing value imputation or encoding, and then feature scaling, train test split, model selection, and as well as applicability of these predictions, and as well as the applicability of the corresponding predictions with the appropriate thing, and confusion matrix, and as well as the accuracy score. Similar. Okay, so if you are talking, friends, even I don't know this particular whatever the metrics we are using from past 3 or 4 algorithm, the same kind of the code we are using. Maybe we have added this accuracy score. Earlier, what we have used, guys, along with the confusion matrix, we have taken the classification report, actually, the classification report. But whereas if you want to come up directly with the kind of the prediction, you can give the accuracy score. Okay, because in a single liner, you can observe the appropriate aspect of identification of y test and as well as the y predictor. Now, if I am asking you guys, just to, with the help of as a task, you can try use the just let me add the task here. Just you can see this very simple only. The task is like that. Apply or else use Cburn or matplotlib to observe the visualizations on this data set. Okay, like pair plot. Have you remember, friends? What is that pair plot? Most famous, which is giving the complete relationship between all the variables, whatever the variable we are having. And then we are having the heat map. Actually, heat map is something like which is giving some matrix format. These two are most frequently used. Along with that, you can go with bar chart or histogram or else some scatter plot, like many are there. So that one liner only, just you can import the cburn as import cburn as SNS, import matplotlib.pyplot as PLT, and try to explore these kind of the visualizations. Okay, however, I will cover some more additional functionalities also, but just you have a look, at least just you can revise these kind of things, so that in the session you can easily grasp the things. Okay, now okay, all these classification techniques up to now are perfectly okay, friends, but there is one more important functionality. If I am talking with if I need to talk related to most commonly used machine learning algorithm, because though we are having these many algorithms, but sometimes, you know, there is a chance of depending on a particular algorithm. Okay, that is nothing but this decision tree, friends. Okay, so which is maybe if I am talking conceptually or statistically, you may feel oh, some kind of difficulty, but it is also not different with the classification algorithm whatever we have seen in terms of coding. I am saying how to refer this decision tree, friends. Definitely it is used for both classification and as well as the regression. This we know pretty well. Second thing, what is the
gives that easily we can arrive at the conclusion. It gives a result easily.
Easily we can arrive. How do you say, Venkat? Is there any specific?
Recursive part, divide and conquer.
That's it. That is the most important thing. Okay, so it is divide and conquer kind of the mechanism. Divide and conquer. Just it is start with the root node. Hope you got the things. Just it is going to split yes or no kind of aspects in a tree fashion. That's what we are saying this as a decision tree orientation. Now, which kind of the data is it is comfortable, friends?
It's like it's only
it is both for categorical. Yes or no. Final answer is yes or no. But your input might be categorical or continuous kind of the data. It is good for either of the data, input data, because in the all the other kind of thing we have seen in the logistic regression actually. What is the property, friends? It is good for categorical dependent variable, like that we have seen. Okay, and divide and conquer, however, we have seen this particular divide and conquer. What it does is it is exploring all those kind of the items, and it is going to perform some kind of the activity. Okay, so just it is performing the recursive applicability of condition checking. Now, to give one example, that day we have seen like wind, okay, whatever the outlook we are having. So to play or not, whether the play is going to happen or not. So just we started with one root node, and if it is sunny and humidity is high, there is no play. If humidity is normal, there is a play. Okay, and observe here, friend, this is the root node. Okay, these are all nothing but the last ones or nothing but the child nodes, friends. These are all the child nodes, and these nodes are nothing but the branch nodes, or which are taking the condition and all. Now, one common question, friends. Okay, one common question, very important. Up to this, you can easily manage. How the decision tree decide the split of the features? Observe here, friends, because just like that I am giving some data to the decision tree algorithm. The main differentiation between the normal algorithms when compared with the decision tree algorithm is our decision tree algorithm observes some kind of the features, actually some kind of the features it observe, and it is based on some kind of the criteria it is going to select the features, because rather than selecting wind, how it is selecting outlook, rather than selecting outlook, here it is selected as humidity. Some mechanism must be there, na? Some mechanism must be there. Can someone help me? That day also we have seen some kind of the measures. Gini index, and as well as the entropy or information gain. Next one is chi-square. Okay, so just we are going to explore these kind of the things one by one. Now, there are certain aspects, friends. Suppose if I'm making use of the decision tree related to the, whatever the features I'm having. So there is a nice observation of these statistical measures in terms of Gini and as well as the entropy. But most importantly, they may ask you what is Gini and whether Gini should be high or low. This is one question. And what do you mean by entropy or information gain kind of thing? Okay, what is the relation and how do you refer? Okay, whether low entropy or high entropy, good or something like that. So these are all most commonly asked questions, friends. I will try to give the answers along with the example. A non-linear strategy will follow here rather than explaining the things manually. So what I'm doing here is just I'm selecting this model. Okay, so just if you observe the decision tree kind of the model, friends, is all things are as usual, importing the libraries or specifying the appropriate aspects, that is as usual. Now let us explore one by one. Okay, on the same data set, so that you can easily grasp what exactly the accuracy score compared with the other models. So as usual, we have imported NumPy, Matplotlib, and as well as the pandas. No differentiation, friends, as that of the earlier case study. The same kind of the example I have taken with the deduction of X values and as well as the Y values. So these are all nothing but the features, and this is the label. And splitting of the data set into training and test split. Okay, just we have selected the model selection component from the sklearn, and we have imported the train test split, and thereafter we have done with all these loading of the data, X train, X test, Y train, Y test with the train test split. Okay, now the point is feature scaling also as usual, because as you know, internally, though it is not using any probabilistic kind of thing, but here why we have done the standard scalar applicability is our data is like that. Maybe if I'm not having these kind of age or salary kind of things, I'm only having some kind of the classification data, then I need not go with the feature scaling. It all depends on the use case, friends. Okay, up to this as usual, we have not introduced any decision tree kind of the model now. Okay, most important thing, intentionally I have given the description in the one notebook only, friends, rather than giving on one note. So observe here, because while practicing also you can have a look, and you can clarify the things. Okay, the first important point is on what basis the decision tree is going to split the data, because some condition might be there, no? And while selecting that particular condition, suppose assume that like this, some people are playing cricket, friends, actually male persons and as well as the female persons. That is one criteria. Second thing is class 9 and as well as the class 10th. That is another criteria. Now, do I need to select the decision based on the male or female or 9th or 10th class? Because there are two options actually. So if such kind of the situations are there, the answer is based on the information gain related to entropy, or else what is the another thing? Gini index. We'll first we'll start with the information gain. What exactly information gain or entropy? Observe here, friends, entropy can be calculated as equation, just to remember, friend, because you need not take pen and paper, and you can you need not show them any applicability, but just like that we have to remember this particular equation. Reason behind this is what is the p value and q value, friends, from the probability? P is probability of happening, Q is probability of not happening. So what we are doing is, you can easily remember this equation, guys, actually entropy calculation minus P log P minus Q log Q. What it is saying? Probability of happening with the logarithmic function, probability of not happening with the logarithmic function. Now there is nothing confusion here, friends. Rather than using the information gain in our model, we are having the criteria as the entropy. So nothing but, friends, your 1 minus entropy is going to give the information gain. Okay, so suppose if they are asking you, what do you mean by entropy? Entropy is nothing but 1 minus whatever the information gain I am having, 1 minus information gain. Suppose if they are asking about especially define how to calculate the entropy, that means minus P log P minus Q log Q. That is the equation of the entropy. So directly this particular entropy is going to perform some kind of the activity of the criteria. So we are going to get some kind of the information here. Now, what do you mean by the information gain? So just 1 minus entropy is going to give the information gain. So this particular information gain helps us to perform some kind of the entropy calculation. Okay, once we got this particular entropy, then you can easily calculate the information gain. Now, the most commonly asked question, whether entropy is high or low. Have a look on this, friends. Entropy should be low. Information gain must be high. Just to remember, friends, gain means what? High, na? Gain. Information gain always should be high. Higher the information gain, the best it is. Opposite to information gain is entropy, na? So obviously our entropy must be lower. That means if you are having minus p log p, minus q log q value, whichever the class is giving the less value, that can be used by the decision tree to follow up the decision. Whereas if your entropy is more, then obviously your information gain is lower. So you should not go for that particular separation. Okay, and calculation. So just it is applying the entropy for the parent node, and thereafter it is going to calculate an entropy for each independent node split and calculate the weighted average of all the sub nodes. However, I will do one thing, friend. Just I will be sharing some examples to you also. Just if you want to explore more on top of this information gain or entropy, you can go and practice those kind of things also, but it's not required. Only the thing is you need to prepare for what exactly the entropy and as well as the information gain calculation. Now simply see here, friends. Earlier we have used the neighbors and we have used some kind of the linear model. Now we are going to use the tree based models. Okay, na? Hope you got the point. So from sklearn.tree import to decision tree classifier. So just I am making use of this decision tree classifier because the decision tree is also there for the regression also. Decision tree regressor like that we are having. So now classifier as usual, decision tree classifier of here what I am doing. I am giving the criterion as, okay, sorry guys, some problem happened. Suddenly it got disconnected. Yeah. Just a minute. Yeah. Now what we are doing here is just we are making use of this particular information gain and as well as the entropy. Okay. So this criterion, maybe I can use the entropy or else in the other implementation, I have given Gini. Okay, Gini I will explain, but you can simply specify criteria equal to entropy or else Gini. Okay, most commonly used. Now let us explore how we can perform the same thing, fitting the model between X train and as well as the Y train. And here the criteria is entropy, so that we are applying some kind of the age and as well as the salary, and you can on top of that particular sample, what is our outcome. And if you are referencing the test result for the sake of observing where we are getting some kind of the wrong observations, predictions, and as well as the model. Now, if you see the confusion matrix, friends, it is giving 91% of the accuracy. Earlier with the logistic regression, on top of the same data set, we got some, how much, friends? We got 89% accuracy score. And you need to explore this confusion matrix also. How many true positives are there? How many true negatives? How many false positives? How many false negatives? Those kind of things also you can keenly observe. So definitely decision tree is doing far better when compared with the naive Bayes logistic regression, especially in the same data set. Now other criteria, what is the other criteria, friends? Our Gini index. Okay, so the tree can be the tree decides because it need to establish some kind of the conditional thing. So earlier we have seen entropy in terms of the information gain, whether entropy should be more or less. Friends, entropy should be less or more. Information gain is more, automatically our entropy should be less. Okay, whereas if I am talking about the Gini index, see here, if you select two items from a population, okay, so this particular population at random, then they must be of the same class and probability of this one if population is pure. What do you mean by pure and as well as the impure? Before calculating this particular Gini, so let me give you what exactly the pure and as well as the impure kind of the models. For that, just I'm having some kind of diagram for you guys. Let me pull that particular diagram. Yes. Okay. Observe friends here. A, B, C, three sets are there. And if you observe, it is a heterogeneous kind of structure. That means all kind of the items are there. It is bit okay. And C is not containing any other things. So here A is more impure and B is less impure and C is pure. Okay. So that means while referencing these kind of Gini calculations and all those kind of things, it is always preferable to have the pure kind of the models, because my whatever the feature I am selecting or whatever the model I am talking, if that particular data is giving some kind of the pure aspects, always my understanding or my explanation or observation related to that particular data is better when compared with the impure kind of the aspects. So based on this particular convention, if I am moving ahead to understand what exactly this GD is, one is okay, one is nothing but is pure. That means if my probability is one, I can say the appropriate whatever the items I'm having is a pure kind of thing. And however, friends, one of the important observation is in case of the entropy and as well as the information gain, there is no restriction, because directly you can apply minus p log p and minus q log q. Based on that equation, you can able to find out the entropy and you can substitute the values. But here it works with categorical values. Suppose your target value is categorical, that means success or failure, then always you can think through the Gini index. Okay, Gini index is better for the categorical kind of the calculations. Okay, it performs only on binary splits. That's what I said now, female, male, or ninth or 10th. If those kind of the splits are there, only two out of these two, one outcome is there, then it only better. Gini is better. Higher the value of the Gini, higher the homogeneity. Okay, that means automatically if we are getting better Gini, if I want to get the better Gini, if I want to get, if I am getting higher Gini, obviously I will be getting the higher homogeneity, which gives the better results. What do you mean by this cart, friend? Somewhere we have seen actually. Any idea? Correlation and regression tree. Generally, you can make use of this particular correlation and regression with the help of this particular Gini. So you can perform, what do you mean by correlation, by the way? Somewhere covariance we have seen, correlation we have seen, just to explore, because see friends, decision tree is giving you some kind of the insight actually, because up to now all the 6 algorithms with a little bit stat you can manage. But if the interviewer asking you in the grounds of decision tree or in the grounds of random forest, definitely you should know entropy, information gain, Gini index, and correlation. All these kinds of things are very much important. Okay, but of course, if you are referencing the Gini, we are having p square plus q square. That's all. Calculating the Gini for the subnode, and once this particular criteria is given as Gini, and it is giving some kind of the rather than taking as entropy, this time we have changed this particular criteria as Gini. Remaining things are as usual, friends. If you observe sklearn.tree import decision tree classifier, and we are fitting this particular model on top of this X train and as well as the Y train parameters, and we are predicting that value, and this also given the same 91% of the accuracy. That means especially in this data set, suppose in case of the if I'm using Gini, I got some 91% of the accuracy, whereas earlier I have used the entropy kind of the calculation, there also I got the 91. Now let us explore these confusion matrix, friends. Let me observe, is there any differentiation between Gini and as well as this thing? This is related to Gini index. These values are related to the Gini index, and let me take what is the other thing? The other thing would be, 1 minute friends, entropy. I should get that confusion matrix for the entropy. Okay, 1 minute. Entropy, because that accuracy score is both same for the accuracy score is same for entropy and as well as the what is the other calculation we have seen? Gini. Okay, 1 minute. Where is this one note? This one note is causing disturbance here. Suddenly it is going to stop, and yes, hope you are seeing one note. Yeah, this is entropy. Any difference, friends? Especially in this data set, there is no differentiation. That means both the parameters practically they are equally likely, because especially friends, you need not work with both entropy and Gini. Never do that, because to explain the concept, I have given the brute force kind of thing. Maybe I'm using Gini or entropy kind of the aspects, but in the reality, we won't go on both the parameters, because either of these things is perfectly all right, because in both the cases, we got some 91% of the accuracy here, and here also we got some 91% of the accuracy. Okay, so now one more point I want to highlight here. Actually, in the decision trees, we are having some kind of the byproducts. Okay, so what is that particular byproduct is one of the important thing is both it is used for classification and regression. This is one thing. Second important thing is works good for both categorical and other thing is continuous. This is one more option. Third and most important thing, feature value, feature importance plot. Okay, so it is providing some kind of the criteria, if possible, just to explore, friends. Otherwise, I'll however, I'm going to cover these kind of the aspects. Okay, so your decision tree model is related to the criteria, friends. Actually, this the most important part here is your decision tree split is based on two criteria, friends. What is the first criteria? Entropy, and or you can say information gain. Okay, information gain. As a sub aspect, I can say this particular entropy, whether entropy should be
less.
Should be less, or else. Okay, just to remember in this way, information gain must be high. Okay, accordingly, the tree, the decision tree, select the split. Okay, important, friends. Accordingly, it is going to select the split. And coming to the second one, what is the other one, friends? Actually, we have used other than entropy. We have seen Gini index. Okay, so Gini index must be more. If it is high, then we are getting the homogeneous kind of the data. So which is a pure kind of the data. So pure import you can easily observe here. This is a pure kind of the thing, so that we can easily observe the better accuracy or better prediction on top of that particular data. Okay, so this is how you can differentiate a decision tree and as well as the things. And now, can someone give the application areas of decision tree, friends? Application areas of decision trees, where we can use and all these kind of the things. So mainly, friends, in case of the medical diagnosis and as well as customer satisfaction or marketing studies, and sometimes the credit scoring, like suppose the salary is more, civil score is okay, and is having age of the loans, like that some criteria would be there now for that, like divide and conquer kind of things, we can make use of these things. And if they are asking, like the interviewers are asking, well, which are all the advantages of the decision tree, how can you say, friends?
It can be applied for both classification.
That is one thing. Second thing. Second thing.
It gives what you call
variable importance plot, na? Variable importance plot it has given. That means basically it is whatever the functionality I'm having. So just it is providing us okay, which are all importance things and all. That means I can say this is the data exploration. Like it is used to it is helping us to identify important or significant variables. Okay, that is one of the important thing, and we can easily interpret the result. And most importantly, friends, are we assuming anything as that of regression and all? It's not a parametric model. Okay, but whereas regression and all basically is a parametric model. And one more thing, friends, actually, what is the which are all the drawbacks of the decision tree? Because always we see applications means credit scoring. Then what we have seen?
medical
medical diagnosis, medical applications, and okay, true enough. And coming to the applications, those things, advantages, if I'm saying,
variable importance plot.
No particularity on data type. This is one thing, input data type. Second thing is data exploration, like feature importance. Definitely I will cover these points, friends, though it is not there in the curriculum. Any other? What is the other point we have seen? It's a non-parametric method. It is not having any assumptions, by the way. Suppose if someone asks you to twist or to grill you, like this thing, which are all the disadvantages? Friends, so what do you mean by overfitting?
Where it doesn't learn, where it doesn't.
That problem is there here actually. So overfitting is more in case of decision trees if you are not properly using that one. One more thing, friends, though this decision tree is performing regression, the performance goes down. Okay, these things though, because simply implementing all the things won't give any advantage, no? So these things you can follow up, friends. Okay, so this is a pretty simple thing which is having many kind of the aspects. So just to think through and come up with the analogy of understanding of the and one more thing, actually in the tomorrow's session I am going to introduce you random forest, friends. Actually in the random forest parameters itself are very good, because in all the other models we are having 2 or 3 kind of the parameters, but in random forest I'll try to put some more 4 or 5 kind of the parameters, which really gives understanding of these kind of the aspects. Okay, now can someone give which are all the key takeaways, friends?
We talked about
What is the first one?
regression.
First we have introduced the logistic regression, and within this we have seen sigmoid,
differences between linear and
linear versus logistic kind of the functionality. And then friends, especially what we have done, implementation we have seen, that is as usual. Next we discussed about the decision trees. We have introduced what exactly a decision tree and all. In this particular aspect, we have seen some of the aspects like entropy, or information gain. Next one is Gini, a Gini index. Okay, these things. And then, okay, as usual, compared with the other models, the advantage of decision tree. Okay, so these kind of things, so definitely in case of the interviews, they may ask you related to this decision tree kind of things, because it is involving the statistical functionalities, friends. Okay, so that is how you can refer the usage of decision tree when other algorithms normal, friend, because it is a simple kind of thing where there is no much statistics or much conflict. Okay, but whereas in case of the decision tree, definitely these things they expects. Okay, right. So, and by the way, just we are reaching to frag end actually. So just to go through the things, and just to come up with whatever the topics you want to emphasize again. So maybe the algorithms or whatever the things, so that we'll have a nice discussion once more. I'll try to give the summary actually. So because I thought of why people are not joining, I don't understand, because the last sessions and all usually
he was well.
not well. Yeah. Maybe they can go through the recordings. Don't, no problem, because recording also they will be given definitely. But unfortunately, because if they are having in the session means the trap out is different. Na? Suresh, Lakshmi, Yogesh, maybe they're all having exams. It seems Yogesh is having some semester exams. He said.
Yogesh went to UK, so he told he will be like, I think he might have reached like that. He is in that phase.
Yeah, no problem. It's okay. But give your best, friends. Just as I always mention, training is different, learning is different. Okay, training closes by 50 hours or 100 hours or something like that, but learning never ends. Okay, because you have to you have to go through and have a look on that. Okay, so that's all, guys. Okay, yeah.
We did not discuss about logistic regression. We just we talked just that the it comes under the classification. So that was the thing.
Okay, 1 minute. So logistic regression, you want me to focus? Okay, okay, no problem. So I'll pull that logistic. No problem.
We did because that we spent some time on decision trees, and you told that forest is like a group of like it's multiple decision trees.
Next session, however, we'll see that.
If whatever, whether you know or do not know anything, you can rely on
yeah, because this is a panacea kind of thing now. Okay, so without knowing, that's what random forest, there one common point we have seen, because if you are not knowing anything, and if someone directly gives the data to you, and if you want to perform some kind of implementation, you can proudly use the random forest. Yeah,
spent one day on decision trees and random forest.
Is session. It? Completely. Yeah, correct. You are right. It is worthful, Venkat, because many at times the people could not how the split is going to done, and what exactly random forest does, and how it could give the better performance when compared with all the other algorithms. So generally, specifically, I am not talking.
You go good example, the one that we discussed, like the male and female playing cricket in that algorithm. There, I did not understand. I looked it, I did not. Then I thought entropy, and I could not. Now I can go back to that.
Yeah, we have seen, because Venkat, our strategy, we followed some non-linear teaching. I have not picked up the things suddenly or surprisingly. That's what I slowly adopted you. This method, though it is taking time and much effort, but it is giving good results from my past experience. What I'm doing slowly, I am aggregating all the things so that you can have a look on that.
Because now I go back and if I do not like remember anything on K cross validation, I can go and refer to bias variance. All those, whatever you have put in, like this one, the purity, everything
is there available.
We can go back and
that is what, Venkat, I am not jumping in between the examples. Also the same examples I am taking, because at the moment you are seeing and going back and verifying that example, definitely you can connect the dots. That is also one of the important things.
And I have seen your YouTube videos, like very crisp, like 10 minutes, 15 minutes on topic.
Oh, yeah. To the point. Yeah.
Whatever topic I want, like I can go back and see if that is there.
That's it. Okay, no problem. And we'll do one thing, Venkat, if you are okay with Suresh also, and we'll talk with other guys also. We'll do some preview kind of things on all topics, Venkat, because people are suffering like for to get the interview questions. Just if I want to get what is decision tree and which are all the models, just 5 to 10 minutes videos, so that it is really helping other members also. I'm planning actually. So if you guys are interested, so just 1 or 2 sessions, we'll complete all the algorithms. Maybe 10 or 15 algorithms are there now. Or just we'll take one example. Okay, these are all the things available in this, to the point, 5 to 10 minutes. That's all. Okay.
What you said at one time, even I believe I observed that so many YouTube. The much of nonsense or something that they try to pull us, saying like, oh, in half an hour you can learn data science, that kind of thing, always they pull around. And of course you have lot of things that they do not discuss. They always that will gain more attention than something that worth
because they all come up with a nice strategy. If subject is weak, then publicity speaks.
Even the knowledge and also the YouTube, TikTok videos will have a lot of influence than something that is of real importance.
Exactly, you are right. That true, Venkat. Because see, that is greatness of the God, I can say, because every member can able to get the what exactly they are knowing and what exactly they need. Then country shape will be different. Okay, that is what we should be in that mode only. Because 10 members are coming to our videos, and because if any member like as you said, the TikTok guys, if they are placing one video, immediately it reaches to some 1,000 or lakhs together views.
There will be like lot of
and see for the fools, if you are writing, definitely your audience would be more. For if I am writing for intellectuals, only intellectuals will study my material, na? That's it. Okay, so that is always there, but we'll after the session also just we'll have a discussion, Venkat, no doubt.
I'm coming to India.
Yeah, definitely, because I'm having some strong setup, so just we want to give some who really needed these kind of the support in data science, machine learning, Hadoop and big data, because people they are passionate about learning, but they could not get the institute like us. Okay, definitely Kumar and Rani are doing really hard. Okay, they're pulling the people, and really I should appreciate them. They're putting more effort, and you see the curriculum is definitely we cannot compare with any other company also, because like that they have made everything, and Even I added some more aspects to that particular curriculum, so it is definitely distinct with other companies. So that yeah, each and every member should contribute. They should they are also they are eligible for strong appreciations, no doubt about that. Okay, we'll do reasonable work, Venkat. Okay, thank you.
Thank
All the best, guys. Sorry to overboard you. Thank you, guys. Thank you. Bye bye.
Thank you, sir.
Thank you. See you back.